Hi guys, I hope you guys are doing well. And in this section, we're going to talk about two things. We're going to tell whether a function is even or odd, and also we're going to describe the graph and describe the transformation in the vertex form, f of x equals a times x minus h squared. So first of all, I want you to pause the video and read the following slide about even and odd functions. And what you need to take away from this slide is that even functions, when you plug in negative x into the function, it becomes the same function. So f of negative x becomes f of x. When you have an odd function and when you plug in negative x, your new function will be negative f of x. So a function y equals f of x is odd when f of negative x is equal to negative f of x. So let's look at a couple of problems together. For the first example, f of x equals 2x. Just like the rule, we're going to plug in negative x into the function. So what happens if you substitute negative x? F of negative x is equal to 2 times negative x, which is equal to negative 2x. So your original f of x, 2x, became negative 2x once you plugged in negative x. So this function is an odd function. So let's try again. G of negative x will equal negative x squared, in parentheses negative x, squared minus 2. You're basically just plugging in negative x in all of the x values. So you get negative x times negative x becomes positive x squared, and then you bring down the negative 2. So your original g of x, it stayed as the same, x squared minus 2. So this function is an even function. And some of you may have noticed that the first question has an odd exponent and the second question had an even exponent. So therefore, that may be the fastest way to look at it. However, there are many different ways to tell whether a function is even or odd. So next question, let's plug in negative x into this function h of x. 2 times negative x in parentheses squared plus negative x minus 2. So all your x's become negatives now, and what you get is 2 times x squared, 2x squared, minus x minus 2. So look at your original and then look at what happened after plugging in negative x. Your function is different. First and the last term stay the same, however the middle term is a different sign. Therefore, this function is neither odd nor even. So now take a moment to pause here and just read over this slide. I know we're switching from even and odd functions to graphing f of x equals a in parentheses x minus h squared. So all this form tells you is that if you're given an equation in this type of form that looks like this form, then use these rules. So far we talked about vertical translations, vertical stretch and shrinks. Now we're going to add the horizontal translations. When your h is positive, when h is greater than 0, then you're going to move h units to the right. When h is negative, you're going to move h units or absolute value of h units to the left. And here I'm talking about the h value, the actual h value, not what it says on the equation. To add to this, the vertex of this form is h0, and the axis of symmetry is h. So let's look at this question and graph. G of x equals half times x minus 4 squared, and we want to compare with f of x equals x squared. The first thing to do is find the axis of symmetry. We were given in this form, so let's use that form. Your axis of symmetry, by definition from the other slide, is h value. So what is the h value in this equation? It is 4, because it's x minus 4, so that 4 will be your h value. So graph the axis of symmetry, and that's the dotted line that I graph, x equals 4. Then the second thing that I'm going to look for is your vertex, or graph the vertex. So in this case, my vertex is h0, which is 4, 0. So that's going to be either my lowest or my highest, minimum or the maximum. Just keep in mind that your a value or the sign in front of your a value will decide whether your function opens upward or downward, as I call it the smile or the frown. And it looks like in this case, I'm just going to have it in the back of my mind that I'm going to be drawing a smile because I have a positive half in the front. The third step is to plug in any points you want to graph a couple of points on one side of the axis of symmetry. So I am going to choose 0 and a 2 because I know that my equation has a half, so it's just easier to work with. And here, what you do is just plug in those 0 and 2 in place of x. I'm just going to fast forward over here. So I get, when I plug in 0, I get 8, and when I plug in 2, I get 2. So those are the 2 points that I'm going to plot. So after plotting those 2 points, I'm going to draw the curve. And what I need to do is basically reflect it over the axis of symmetry. And I get 6, 2 and 8, 8. So now what I have to do is compare this graph to the graph of f of x equals x squared, which is my parent function. So here's f of x equals x squared. And I can see that my new graph g of x became wider, and that's because of that half in the front, the a value, and then it moved to your right, and we'll see how many times. 4 times. So you can pause the video to write the comparison down on your own and then check with the answer. So the next concept is just adding another portion into what we were just talking about. And now I'm going to add that k value on the outside. So this is called a vertex form, very similar to the one that we just talked about. And what this does is we're going to move it horizontally and also vertically. So h is going to be horizontal translation, and then k is, you're going to move it up or down k units vertically. So as we talked about before, your vertex is now hk, not h0, and your axis of symmetry is still h. Just to quickly go back to the original slide that we were talking about, this is also a vertex form kind of in a sense because your k value is 0 in this case. Alright, so here's the next question. Graph g of x is equal to -2 times x plus 2 squared plus 3. First, graph axis of symmetry. And your axis of symmetry is your h value, which is, in this case, a -2. Because your negative, it negates each other, becomes a positive. So now my dashed line will be your axis of symmetry at x equals -2. What is your vertex here? I know that this function is a frown. So because of that -2 in the front, the a value, so my vertex is going to be my highest, my maximum value in this function. Vertex is hk by definition, and hk is -2, 3. So let's graph that. And step 3, plug in random points. What I recommend you do is to look for the points that are close to the vertex. For example, -3 and -4 maybe. So I'm going to fast forward this part so you can pause the video and do the work on your notebook and then check your answers. So now I'm graphing -3, 1 and -4, -5 on my left side of the axis of symmetry, and then I'm going to reflect those points by counting the steps, or you can plug in more points if you want. And as I've told you, this is going to be a frown and downward U or downward parabola. So I get -1, 1 as the other coordinate, and 0, -5 as the second coordinate. So connect the coordinates, and that is your g of x. Now let's compare with your parent function f of x is equal to x squared. And here is your function f of x equals x squared. And now let's look at what happened from f of x to g of x. it first of all moved up 3 times vertically, and then it flipped over the x-axis, and then it stretched vertically because it became skinnier, g of x became skinnier, and then finally it moved to the left. So let's write all this down. So the vertical translation, 3 units up, is represented by the k value, which is plus 3 of g of x. And then the reflection over the x-axis is represented by the negative sign in front of the a value. The vertical stretch is represented by the a value itself, 2. And then lastly, your horizontal translation to the left 2 units is represented by your h. For this last question, I want you to pause the video again here and read the following word problem. And focus on the last part of the question itself, where it says write and graph the quadratic function that models the path of stream of water with the maximum height of 5 feet. Vertex is 3, 5, and you have a landing on a spotlight 6 feet from the water jet, represented by 6, 0. So the very first thing I would do here is to rewrite your vertex form. We just learned that the vertex form is f of x equals a times, in parentheses, x minus h squared plus k. So let's rewrite that. And the reason why we use this vertex form is to find the a value. So what we're going to use are those information given by the context of the question, which is the vertex, and I know vertex is hk, so 3, 5. So plug in 3, 5. Then my next step is to plug in my x and y, which is given by the information that other point was 6, 0. So 0 equals a parenthesis 6 minus 3 squared plus 5. And now I can solve to look for a by itself. So 6 minus 3 is 3, so 3 squared is 9. And 9a plus 5 is equal to 0. Subtract 5, divide by 9. You would get a is equal to negative 5/9. So all I need to do now is to finish up my problem by writing f of x is equal to negative 5/9 times x minus 3 squared plus 5 as my final answer. So that's it for today. Great job. I'll see you in the next lesson. Bye-bye.